Today we'll look at a quick and easy way to sketch a basic tangent graph. We'll do the example y equals tangent 3x. All right, so for reference, we have the general form of a tangent equation, and then we have an outline to follow. So start with step 1. Let's find the essentials. A, nice and easy, it's the leading coefficient right in front of the tangent. We don't see a number there, so we understand it's a 1. And that's going to help us with the y coordinates for some of our points in our key points pattern in step 2. So we'll come back to that. B is the coefficient of x. So in our case, it's 3. And that's going to help us find the period. So for tangent, be careful here. The formula is pi divided by b. So our period for this equation will be pi divided by 3. And remember, period is just the horizontal length of one cycle. All right, as soon as I get the period, I like to divide it by 4. And I do that because then each key point in step 2 will line up nicely with a horizontal tick mark. So let's show it. Pi over 3, dividing by 4 is the same thing as multiplying by 1/4. So we'll count each tick mark by 1 pi over 12. All right, so let's take a moment and do that now. We're just going to show one cycle graphed here, and we'll count 1 pi over 12, 2 pi over 12 reduces to pi over 6, 3 pi over 12 reduces to pi over 4, and 4 pi over 12 reduces to pi over 3. So notice that this fourth tick mark to the right of the origin matches our period, and that will happen every time with this setup. For the vertical scale, it's really easy. Look to that value of a. Since it's 1, we'll just go up 1 and down 1, and we're ready to move on to step 2, where we will plot our key points. All right, so the key points pattern for tangent starts at the origin, and it just goes 0, point, a curve setting point if you want, asymptote, and then the lower curve setting point. So start at the origin. Here's our 0. The upper curve setting point happens at pi over 12, and to get the y coordinate, come back to that value for a. So 1 will be the y coordinate here, and this helps shape the tangent curve. All right, vertical asymptote happens at that second horizontal tick mark moving to the right. So there's an asymptote at x equals pi over 6. And then our final point will be that lower curve setting point. It'll happen at pi over 4, and to get the y coordinate, just take the opposite value of a. All right, and then the pattern would start to repeat at pi over 3, so we'll put another point for a 0 there. And we're ready for step 3. Let's sketch in this tangent curve here. All right, so we're showing kind of a split cycle of tangent here, one full cycle, and repeat this pattern for as many cycles as you need to get a great tangent graph. Before we go, one final helpful tip. If you are looking to find all of the asymptotes for this graph, or the equation for the asymptotes, there's a really easy way to do this. All you have to do is take your horizontal transformations, or your inputs of your tangent function. So for this equation, it's 3x, and set that equal to the original asymptotes for y equals tangent x. So those happen at pi over 2 plus pi k, where k is an integer. Once you have this little mini equation, just solve for x. So we will divide every single term by 3 or multiply by 1/3 if that helps you. And our asymptotes equation for this graph is x equals pi over 6 plus pi over 3k. And so for example, we see we have that asymptote that we graphed at pi over 6. If you substitute in 0 for k, this equation gets you that asymptote. And then if you would like a different asymptote, simply sub in a different integer. So for example, 1 or -1 for k, and calculate to find those asymptotes. If you'd like more help with finding vertical asymptotes of tangent graphs, be sure to check out the link I'll put in the video description. That will take you to a playlist for more examples of tangent graphs and for a lot of help with asymptotes. Subscribe for more tips, and thanks for watching.